So now we're going to talk about electrolytes and non-electrolytes, and this is going to look very much like a lab we just did. Okay, so with electrolytes and non-electrolytes, electrolytes in the body play an important role in maintaining proper function of the cells and the organs. Electrolytes such as potassium, sodium, bicarbonate, chloride can be measured in a blood test. So our goal here is to describe first of all what electrolytes do, and identify solutes as electrolytes or non-electrolytes. Okay, so first of all, electrolytes essentially can conduct electricity. Okay, so strong electrolytes dissociate 100% in water. They produce positive and negative ions. Okay, and they form solutions that conduct electricity, that conduct electric current strong enough to light a bulb, which you saw in some of the videos for lab. Okay, so sodium chloride, you know, dissolves very nicely in water. It's just salt water, right? Sodium chloride dissolves very nicely in water. It dissolves completely to make positive and negative ions. And when there are positive and negative ions in solution, then it turns out the water can conduct electricity because of these ions, right? They're going to the negative anode, and the negatives are going to the positive anode. I think that's a cathode. I get cathodes and anodes mixed up. They're going to the negative electrode, and these guys are going to the positive electrode because of their charge. Now, weak electrolytes do not dissociate completely, right? So here we said they dissociate completely in water, but weak electrolytes do not. So hydrofluoric acid is an example of that. Hydrofluoric acid is a weak electrolyte because it dissociates only slightly in water, and it forms a solution with a few ions and mostly undissociated molecules. So for example, if you take HF and put it in solution, most of them do not break up. They still dissolve, no problem, right? But they mostly do not break up. And the ones that do, though, will conduct electricity, where your positive ions go to the negative electrode, which I think is the anode, and the negative ions go to the positive electrode, which I think is the cathode. All right, so weak electrolytes do conduct electricity, but you can see up here this bulb. Let me compare that to the previous slide. In the previous slide, this is very bright, right? And that's going to say, we're going to say, oh, well, that must be a strong electrolyte. But here, if the bulb is not burning so brightly, we'd say, oh, that's a weak electrolyte. Okay? Now, with non-electrolytes, the bulb doesn't go on at all. Not at all. Why? Because the solutes do not break up into ions, right? So methanol, we've seen this before, if you add that to liquid water, it will dissolve and make aqueous methanol. But it doesn't break up. It just stays as molecules, and it does not conduct electricity in solution. Okay, so solutes in aqueous solution, just as a review, strong electrolytes dissociate completely. They're only in ions, and yes, they do conduct electricity. Examples are here. Salts, you recognize those, ionic compounds. Okay? Weak electrolytes, however, they dissociate only partially because they mostly stay as molecules, and only a few of them turn into ions. So we would say that conducts electricity, yes, but weakly. Okay? HF, water, breaks up a little bit, but not much. Ammonia, acetic acid. Okay? All right, in non-electrolytes, they do not dissociate at all, and they do not conduct electricity. Example, those would be methanol, ethanol, which is essentially, when we say alcohol, we're talking about ethanol, sucrose, which is table sugar, and urea, which is not table sugar. Okay, so let's do a learning check, and pause the video, and have a look at this, and make an attempt at this, and then come back and see what I say. Okay, so complete each for the strong electrolytes in water. So calcium chloride, you recognize that is a soluble compound, and so that is going to dissolve as calcium 2 plus, and calcium 2 plus and 2 chloride minus ions. Not that. Right? 2 chloride ions. Okay? The next one, potassium phosphate, that's going to break up as 3 potassium ions, and that's the only one that's left, right? So it's going to be that, phosphates. 3 potassiums and 1 phosphate. All right, so it's going to be, looks like it's going to be C here and A here. All right, let's do a couple more learning checks. Which of the following reactions represents a dissociation of a strong electrolyte in water? Which of these is a strong electrolyte dissolving in water? Pause the video and see what I'm going to say. Okay, so I'm going to suppose you paused it, and I see that this is not breaking up into ions, right? We already learned that ammonia was not a strong electrolyte. This is not breaking up into ions at all, right? Ammonium, aha, there we go. Break up into ions. So this is the one. It's going to be C, because I've got ions, right? That's a strong electrolyte because it breaks up into ions. And this also does not break up into ions. So definitely it's C, and there we have it. Okay, let's do one more. Write the equation for the formation of a solution for each of the following. Pause the video, write the equations, make a guess, and come back and check your answer against mine. Okay, so first of all, potassium, I think this is chromate, right? Dissolves in water to give 2 potassium ions, right? Plus a chromate, 2 minus. Okay, the partial dissociation of a weak electrolyte, phosphoric acid in water. This is a weak electrolyte, so this is going to be going to give 3 H pluses plus phosphate. Right? Really important, really valuable for you to recognize these ions by now. Right? Chromate, phosphate, really valuable if you recognize those. And then the final one, the dissolving of solid sugar, it's sucrose in water. And this is just going to be C12, H22, O11, solid, dissolved in water is going to give C12, H22, O11, aqueous, because it does not break up into ions. And you know it's not ions because there's no metals in there, right? Okay, so finally, just as a nice little round out, let's look at the typical concentrations of electrolytes in blood plasma. This is interesting. How much sodium do we have in blood plasma? Milliequivalents per liter. That's just a unit I don't want to go over with you, but just give you sort of comparisons. 135 to 145 milliequivalents per liter of sodium. Potassium, wow, way less. Calcium also way less. Magnesium, less yet, right? Chloride, up there pretty much, closer to sodium, right? Bicarbonate, right? And phosphate. Bicarbonate's huge compared to phosphate, right? Here are the 2 buffer systems in your blood to help keep, thank God, to keep your pH, your blood pH, pretty stable. All right, interesting. I won't go through the rest of it with you, but you can see there's more information in that table. Table 9.6 from your text. All right, hope that's helpful. We talked about electrolytes here, strong electrolytes and weak electrolytes, and how we know what they are.